Assalamualaikum and a very good morning to the coordinator Encik Fuad bin Abdul Latif, my supervisor Puan Yusindawati binti Muhammad Yusuf and my fellow panels. My name Muhammad Asri bin Sabri. Today I want to present to all of you about my final year project which is entitled Carbon Monoxide Detector in Vehicle using IoT for Safety Application. The carbon monoxide is a poisonous gas that has no odor, is colorless, and has no taste. Because carbon monoxide is a colorless and odorless gas symptom of CO poisoning might be difficult to detect, thus making CO a hidden killer in the vehicle. The table tabulates the concentration level as stated by Occupational Safety and Health Administration. From 0 to 200 ppm is the safe level and 200 until 800 will cause physical symptom. 800 and above is a danger CO exposure will lead to fatal. Besides that, what causes CO poisoning from vehicle? Based on the question, that is because the operating vehicle with defective exhaust system and emission system. Second, driving vehicle with trunk lid or rear tailgate open. Third, driving vehicle with 8 hole in the car body. And lastly, operation vehicle in a garage, car or any closed building will cause CO poisoning from the vehicle. The problem statement for this project was the symptoms of CO poisoning are difficult to recognize, making CO a hidden killer. Next, the leaking of the vehicle exhaust system will lead a high risk to the human. Besides that, the CO poisoning always occur in our community. To prevent the CO poisoning, the project was created to detect the presence of CO. The objectives are to analyze the concentration of CO at danger situation and develop alert and monitoring system for the carbon monoxide gas using Blink apps. Next, this is a system architecture design for the project. This system consists of the gas sensor as an input of the system. The signal of the gas sensor then was sent to microcontroller. The microcontroller no MCU that equips with Wi-Fi module was used to send the data of sensor to Blink Cloud and LCD display as an output of the system. From the Blink apps, it can show the notification on the email on the smartphone, and it is also being used for viewing the real data of the carbon monoxide. Furthermore, the flowchart of the system. The system starts with establishment of the connectivity of the internet with microcontroller. Once the connectivity was ready, the gas sensor begin detecting the presence of CO and send the data to the LCD and blink application through the microcontroller. If the concentration of CO less than 200, LCD will display nice. If the concentration between 200 and 800, the LCD will display OK. Then if the concentration between 800 and 1800, the LCD display high and the Blink app will notify please alert if the concentration above 1800, LCD will display high and at the same time Blink app will send the notification and email to make sure the user alert with the presence of CO gas. Next, the table shows the standard CO concentration level by OSHA. Based on the table, CO concentration is less than 200, the amount measured is normal. The level is safe if the concentration is between 200 and 800 ppm. Then the level is precautionary if the concentration is between 800 and 1800. Concentration is dangerous if it exceeds 1800. The data analysis for the project was based on comparison between a moving car and a static car. The data was collected at Pedagang, Pertam and Sungai Petani Residential using country car. The data has been recorded nearly for 2 weeks from 5 to 20 November. The prototype was placed in the car and it took roughly 30 minutes to collect data for both modes. Carbon monoxide measurement and graph data are displayed on the graphs at the super chart. Next, the sample of the electric message that will send to user if the concentration of CO above 800 and below 1800 ppm. The system will continue notify the message to the user until the concentration of CO decrease below than 200 ppm. Next, The prototype of the carbon monoxide detector in vehicle using IOT for safety calculation was shown in the slide. The project was powered by a power bank which served as the project primary source of the power bank. The power supply might provide 5 volts to the node MCU. The main sensor for the project was MQ7 sensor that required VCC 5 volt from the power supply to maintain a stable value of CO and the ground. The MQ7 and the node MCU are connected via pin A0, which is an analog pin. The LCD display that comes with I2C chip were connected to D1 and D2. SDA pin was connected to D1 and SDL was connected to D2. Next, for blink interface, at the top of the system, it shows the start and stop button. As from the graph widget, it shows the reading value of carbon monoxide ppm. The go widget displays the reading of CO ppm. The graph has the time interval function that the user can keep track on the reading from either live 30 minutes or 1 hour ago on its x-axis and reading value on the y-axis. Besides, it has the feature the exporting graph data to email to be analyzed later. Next, the result and the finding at Penaga and Bertam. Firstly, the result at Penaga. The presence of CO is higher while the car is in static mode and than when it is in moving. The surrounding environment was safe because the standard CO ppm was below 200 ppm. The trend line for graph static mode is increasing and moving mode was continuously. The reading of CO at Penaga was higher because the temperature and the humidity at Penaga was cold because the raining season. Carbon monoxide poisoning occur in cold month and a lower temperature. Next, the result at Batam Residential. Based on the chart, CO has been fast increasing at 14 minutes while in static mode, indicating that the level of carbon monoxide present at the residential must be monitored. This is due to increasing surrounding temperature and humidity. The moving mode of the car at the time showed the constant reading. This is since the catalytic converter was in use, reducing the amount of CO in vehicle. The catalytic converter is ineffective during a cold start. Furthermore, the concentration of CO at Sungai Petani is displayed in the slide. The results show that the static of the car produces more CO compared to moving car. This is because the amount of CO is much higher during initial startup and decrease dramatically after the catalytic converter warms. Continually starting the engine produce more than letting the engine run. Aside from that, statistics from Sungai Petani suggest that the pressure of carbon monoxide is average or constant CO. As a conclusion, this system successfully detecting CO in a dangerous scenario. All the IOT have been achieved. With the Blink app, user is aware of the carbon monoxide reading, which help them monitor the level of CO in their vehicle. Aside from that, user are also get notified or alert if CO exceed 1800 ppm, where the system will activate the warning or alarm system. From the analysis, Panaga had the highest carbon monoxide value while Sungavani had the lowest carbon monoxide reading because the temperature at and the humidity at Panaga was cold because the rainy season. However, carbon monoxide reading at three locations were less than 200 ppm, indicating that the area was free of the poisonous gas. In the future, it is proposed that users use GPS to assist them in determining their location. That's all from me. Thank you.